Hi and welcome. My name is Idan and we are planning to start our journey. New technologies like cloud computing are always an interesting subject, and that's great. But I always like to understand things a little bit more deeply and still see the big picture before running into more details. We should always try to connect between a problem or a challenge and the relevant solution. Cloud computing emerged as a solution to solve specific problems. So, the first step in our journey is a little bit about history. Where and why everything started, where are we right now, and where are we probably going to be in the near future. The whole IT market is transforming and changing shape based on small evolution steps into a completely new creature, and this is the cloud revolution. Long time ago, okay, maybe not so long time ago. I'm talking about few years looking back on the IT market. The IT infrastructure in most organizations was completely owned and managed by each organization. It was usually on premises IT deployment in one or maybe two data centers where almost all applications were running inside organization data centers. Any software application that was used inside the data center was license based and also used specific physical resources like servers, network connection, bandwidth, and storage capacity. The IT team was doing and controlling everything, planning what kind of hardware will be needed in the upcoming years, and then started a long purchase process to buy this very costly hardware setup, install that in the data center, and of course configure and operate those resources for the benefits of all end users in the organization. Basically, it is quite logical life cycle: plan, buy, install, operate, and start all over again when demands are changing. The organization must invest in hardware, software, ongoing upgrades, maintenance, support, customization, and of course, manpower. And all of those items are translated to money, the capital and operational costs that are associated with handling IT. Now, this traditional IT model was quite good for many years, and we will be able to find many organizations that are still operating in such mode. Now, something very useful we need to define and use as early as possible is the concept of application workload. Any software application that is running and performing a specific work consume resources like processing CPU, memory, network bandwidth, etc. The consumption of resources can dynamically change according to the behavior of the specific application. Think on some email exchange servers. As more users are connected to the email accounts, then the load on that email application is rising, consuming more resources. Measuring application workload is important, and it is used for a variety of use cases. Basically, we would like to know if the allocated resources are good enough to the application load. If something is not right, we can do something about it. For example, when you consider to buy a new laptop, then probably you will be able to find many application workload tests being performed to evaluate the hardware performance of that specific new laptop. So in such case, a defined workload can be specified as a benchmark when evaluating a computer system in terms of performance. How easily the computer handle the workload, what is the response time for a user request, and how much work is accomplished over a period of time. Another example that is more related to our subject is to measure all kind of parameters on the hardware equipment running a specific application, helping to evaluate the load in a given time. It can be the CPU and memory workload, input and output throughput, available storage capacity, network bandwidth, and so on. Now let's start to use the concept of application workload in the context of traditional IT. If you will ask some IT manager, his or her biggest challenge is the problem of resource allocation. At the end, there are limited amount of physical resources that can be allocated. The IT team bought a specific amount of servers based on limited budget, and the servers were divided to the application workload running in the data center. As a simple example, here we have two applications, A and B. The vertical line on the left side is the application workload over time. In addition, for application A, the IT team allocated 2 servers, and for application B, they allocated 5 servers. Now, looking from left to right, we can see the application workload patterns in specific time interval. Let's assume this is over the last 24 hours. Now, you are the IT manager. What kind of problems do you see here? Think about it for a few seconds. There are two main clear problems we can see here. The first one is that during the peak time, application A and application B are using almost all allocated resources, reaching the limit. Okay, application A is reaching the 2 servers maximum allocation, and application B is reaching the 5 servers maximum allocation. They can't grow and expand to additional resources. This was the allocated resources for each one of them. In that case, this problem is called overutilized resources, as during the peak time, the resources are becoming a bottleneck. The second problem is called underutilized resources. It can be on average, for example. Take a look on this point. The workload on application B is almost 0 or very low, and in parallel on the same time interval, the workload on application A is at the peak point. Now, it is quite obvious that it makes sense to utilize the unused resources allocated to application B and move them to application A just for this time period. But assuming those applications are running on separated servers, the resources cannot be shared, and most of the time they are actually underutilized in idle time. Now imagine you have 200 servers in the data centers running 100 applications, and we have much more complicated situation. The good news is that this problem was solved to some level using a new imported technology that was developed for helping to optimize the usage of resources inside the data center. I assume you're already familiar with the concept of virtualization, so I will explain that quickly. Virtualization separates resources and services from the underlying physical delivery environment. Now, with this approach, we can create many virtual systems within a single or multiple physical system. If we have physical resources like servers, storage, and network devices, we can use a virtualization management layer that is called here hypervisor, sitting on top of the physical resources. Now, using this hypervisor, we can divide the underlying physical resources to multiple virtual resources, also called virtual machines. Each virtual machine is like a dedicated virtual container with specific operation system and specific application running inside. The move into virtualization technologies was a useful evolution for traditional IT, of course helping to handle the issue of more dynamic resources usage and ongoing optimization across the data center, making the IT infrastructure much more efficient and flexible. It will be very hard today to find any data center worldwide that is not using virtualization technology. Now, everything was fine until the internet or the World Wide Web completely changed the way application and services are consumed. And this is the subject of our next chapter. Consumers, like you and me, are constantly use services and application over the internet to access and manage data. All our searching is done online. We upload data to social media sites, accessing our email accounts, designing some electrical circuit using a web tool, storing files or data in some cloud service, and much more. Our internet speed and performance is not an issue anymore. Consumers are already using cloud services for accessing content and services on multiple devices, delivered to almost anywhere users are located. Some of those services are so useful that it will be hard to imagine our life without them. Now, what's the relation to cloud computing? Those services are called SaaS, software as a service, and they are actually the first cloud-based services that emerged in the consumer market and then slowly moved also to the business market. Application and data are sitting somewhere in the cloud, managed and operated by someone else, and we as end users or customers are getting online access from any location worldwide. We just care about things like experience, performance, data, integrity, and in some cases also for the level of security and so on. Moving from the consumer market into the business market, where organization can be the customers for such software as a service application, think about the average company that we can see here in this simple diagram. There are several branch locations connected to some central data center where there are countless software applications being used by end users for their daily job. Now, what if we can take some of those applications and move them to the cloud, to the internet? And the first pioneer of this new software as a service model for the business market was a company called Salesforce. They started to provide a CRM service over the internet instead as a license-based application installed in the organization data center. And that was a starting point for a major mind shift for the business market that was used to buy software and hardware. And their success actually started the SaaS race, where more and more software vendors started to move in that direction, and today we have quite comprehensive list of applications that are now proposed as a service for the business market. Now you can ask me, what's the relation to traditional IT data center that we just learned in the previous chapter? Okay, that's a good question. This new SaaS market trend was also a major evolution step in IT when companies started to shift some of the application installed in their data center or maybe in multiple desktop computers used by end users into the cloud-based services running on top the internet and being provided by a third-party service providers. On our last chapter, we discussed on how new cloud services called SaaS, software as a service, started in the consumer market and then evolved also into the business market. And that was the first wave of cloud computing. Now we are ready to move to one of the most important and interesting market trends across almost all industries that will help us understand the big picture. It is called the digital transformation. Our world is becoming more connected than ever before. New super smart technologies, are keep being embedded everywhere we go, and it's transforming the way we live, work, buy new things, learn, play, communicate with other people, and so on. On the business side, the digital transformation is reshaping completely all kind of legacy business models into the future where everything is around ideas and data. There are some companies that are leading this amazing transformation, and as a nice example, let's take Amazon Echo on the left side and Google Home product. Those devices are nicely designed with all kind of interesting features, but by themselves they are quite simple piece of technologies. Now, because they are connected to the internet and use all kind of cloud-based services to get and analyze data, they are becoming very powerful devices. And the power is keep growing as the clouds in the background are becoming larger and smarter. Now, this new power is actually divided between us, the consumer, with what we can achieve today with product that cost below $200. And on the other side, the power is of course being used by those companies as they can utilize and monetize the data that we keep generate. Now, growing amount of companies in the business world understand that the power is actually shifting to the consumers as they are expecting more value for less money, better services, better communication options, and so on. And of course, all kinds of technologies are becoming more useful when a specific business would like to better understand the market, what customers are looking for, what is their experience, and so on. It is clear that because more and more actions are being done online using websites or any end device connected to the internet, like we saw just in the previous slide, many things can be monitored, measured, analyzed, and then be translated into some useful data. When we search something online or upload something to the internet, this information is dynamically analyzed and then sold somehow to other companies that can make money from this data. This is the digital age where data is becoming at the center of many business models. Okay, think about an online supermarket site. You have thousands of people that are searching and selecting product using the site. It will be extremely useful to understand right now, in real time, that a growing amount of people or users are searching a specific product over, let's say, the last 5 hours. Based on this information, the supermarket can decide maybe to order more units of this product, or maybe share this information with the supplier, or maybe create some discount deal. And we will be able to find countless more examples on how this data can be monetized and be used to make more money. The digital business model is basically more and more data-centric. Everything is around data. How can we collect, store, and analyze this data for making smart business decisions? Companies are looking for ways to put digital at the center of their businesses, otherwise they will be out of business. This is the digital transformation that many organizations are trying to achieve, and the demand for technologies helping to move in that direction is keep growing. How to monetize data, be more flexible, provide better service, invent new digital business models, be more connected with customers, and better collaborate with partners. Now, if I will summarize the main needed characteristics of the digital business, it will be: the faster the company can get new ideas to the market using innovation, the better the company can collect, analyze, and predict data almost in real time and make decisions on top of that. And last thing, the quicker the company can adapt the services and the product based on customers' feedback. But the private data center that we discussed so far in traditional IT is not really designed to support such growing and keep changing business demands that are based on ongoing innovation. Now, as a simple example, a specific organization would like to focus on new business model, allocate resource as soon as possible, test that in the field, and maybe after 5 months kill that initiative because it's not really working, and reallocate the resource to other projects. This kind of agility is needed as things are becoming more dynamic in the digital age. In addition, applications are now more connected to the internet, and end users are creating much more dynamic application workloads. And again, the private data center is quite limited to handle such demands in the context of scalability. In addition to that, now we have more data source to handle. Okay, more places that we can collect data. The volume of data is getting bigger, and there are more variety of data types, different types of data that we need to collect and analyze. Now, in many cases, big data and all kind of analytics technologies are added to the organization data centers, helping to manage and maybe utilize this data somehow. But the reality is that not all organizations are in position to use sophisticated technologies. Not everyone are Google, Facebook, or Amazon. Most business or organization can't enjoy those new technologies for many reasons. And it makes sense that some level of abstraction layer is needed for helping more and more organizations and companies to take advantage of such technologies. And now we are getting to the main value proposition of cloud computing, providing an abstraction layer to super complicated technologies being used in the cloud and providing new types of services that are needed for companies to take advantage and help them while going into the digital transformation. Now let's speak about cloud computing. The first company that understood the business opportunity of cloud computing as an infrastructure solution was Amazon. Okay, during 2006, Amazon introduced the Amazon Web Services, or in short AWS, that provides on-demand cloud computing platform to be used by individuals or companies on a paid subscription basis. Basically, AWS is a huge collection of IT infrastructure, including servers, network devices, and storage space located in multiple worldwide hyperscale data centers that are connected with super fast networks. The idea was simple but still brilliant and quite innovative. if companies are struggling to build and maintain their private data centers with the top available technologies in the market, then Amazon can do that for them. Now, those companies, like we see here, will be connected to a central cloud service centers where they can dynamically allocate the needed resources from a shared pool of resources managed by the cloud service provider, in our case Amazon. And now they will be able to utilize the most powerful technologies already implemented and used inside the cloud. In that sense, cloud computing started to fulfill some of the capabilities that were missing in the market for helping organizations in their digital transformation process. If we will use the official cloud computing definition from NIST, the National Institute of Standards and Technologies, then cloud computing is a model for enabling convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. Okay, this is something we will break into pieces in our course. In addition, this cloud model is composed of 5 essential important characteristics, 3 service models, and 4 deployment models. Now, this definition is so useful that we will use that in later section in our course to break down the cloud computing to its basic components. Now, can you guess what really happened when cloud computing was introduced by Amazon AWS? Well, not so much. In those early days, cloud computing was really considered, as a strange concept that is too drastic a step for the market. And most of the IT and software market ignored this new concept, including business customers, software vendors, and even competitors. Amazon were running this new business line, Amazon AWS, without any competition for several years. They actually started to educate the market. Now, small startup companies were the first early adopters of cloud computing and the first customers of AWS, but other companies, medium and large size companies, almost ignored this new cloud computing wave for all kinds of reasons. Some of them are saying it's not safe, it's not secured, it will be more costly to rent services than buy them, as they used to do for so many years. They don't want to lose control over the application, over data, and of course other reasons. Now, after a few years, other giants like Google, Microsoft, Oracle, and many other companies understood that the market is shifting in that direction and it will be smart to join in. Think about a company like Google that was already operating hyperscale data centers worldwide for all kinds of web services, like Google search, of course, and YouTube's. Google are already doing that for many years, okay, and quite well. And it makes sense that it will use the same infrastructure as a new business line and become a cloud provider for organization. Now today, after more than a decade, Amazon is still the biggest player in the market, and I don't think it will be changed a lot in the coming years because of their early starting point. But other competitors are closing the gaps quite fast, at least from the technology part, and some of them are already offering almost similar product and services. and each one of them is taking a little bit different direction, trying to differentiate their offer in the market. Fast forward to this time, almost we are starting 2018, and probably few years into the near future, cloud computing is becoming a more matured and accepted solution for replacing or even enhancing traditional IT. It was started as emerging new technologies, and now it is an established internet-based solution that is gaining widespread acceptance. More and more business companies and organizations are moving in that direction. As a result, the market movement is already influencing multiple industries, and it is really considered a major disruptive force in the market. It is completely changing the IT industry, transforming the basic business models that were used for so many years. But more important than that, the horsepower of public cloud services are now available to everyone, to every company that is smart enough to utilize it for their business advantage. Cloud computing is not really just about saving money. It is perceived by more and more companies as a catalyst for innovation. We already saw that digital businesses require speed and agility that cloud computing can provide through the use of cloud services, because it enables global reach of services and information through an elastic computing environment that is easy to use. I would like to remind you that this is one of the reasons why it is important to invest in cloud skills. The market demands for cloud skills is increasing in multiple directions, from developing new cloud application, migrating existing application to the cloud, promoting and selling cloud solution, utilizing new advanced services offered by cloud providers, and so on. More than that, innovation across multiple industry is rapidly shifting to the cloud, and we will see more and more vendors, companies that provide product and services, they will provide their solution mainly in the cloud, meaning their product and services will be available mainly as a cloud services. Now, the cloud is also become a catalyst for small business growth, because it allows them to innovate and more easily penetrate to existing well-established market, and even create completely new market, new business models, while disrupt the current status quo. And new types of business models are already entering the market. Taking, for example, the whole e-learning market like Udemy, digital banks, all of them are heavily based on technologies, digital data, analytics, network connectivity, and so on. The adoption rate is growing. Big companies started to embrace it as a strategic decision to focus on the core business and utilize the power of cloud services. If you can't fight it, join it. Enterprise and government organizations are moving also to cloud computing, placing more mission critical workload into the cloud. Multiple cloud service providers are in growing competition. We saw that. Who grab more market share in this growing cake? And yes, cloud computing is really becoming the mainstream. Everything is online and connected. I don't want to scare you with some science fiction movies and the buzz around it, but artificial intelligence is one of the main directions where the cloud computing industry is trying to go today, and also other industries, like for example connected cars. It is becoming a race between the big players. Now, why do you think it is becoming so important for cloud computing? Well, two reasons: data explosion and real-time requirement. In a growing amount of consumers in industry application, it is required that system will be able to automatically collect data, analyze, learn, adapt, and respond in real time without human intervention, or at least with minimum human intervention. Many of us already use some form of artificial intelligence almost every day. For example, speech recognition is usually classified as artificial intelligence, as it is quite complex task to translate what we are saying to text that can be analyzed. Now there are growing number of software and hardware solutions that are trying to utilize machine learning algorithms for pattern recognition and use that data to train, learn, and become even smarter. I think it's quite interesting and important subject, so I'm planning to develop a dedicated course just about this topic, hopefully in the near future. Now again, what's the relation to cloud computing? Well, this can be a classical example of the value proposition coming with cloud services. Just think about a small company, like a startup, that can instantly use the horsepower of artificial intelligence without trying to develop such capability in-house. Such advanced artificial intelligence services will be offered by the cloud providers to anyone that is willing to pay, with the needed abstraction layer, making it simple to be consumed and used. Okay, that's all for this section. Thanks for watching so far. I hope it is interesting. Now it's time to move to the building blocks of cloud computing.